Section 15 onwards talks about areas where it's not possible potentially to attach to the fabric of the building. We've got multi-service penetrations, or perhaps we're using modular build. In which case it says the resistance to fire of the cable containment system should be at least equivalent to the survival time required for the cable. And in section 15, it notes failure to observe the design criteria will result in the premature collapse of the cable containment system and the circuit failure of the cables being supported. So we know the support system should have a fire survival time equal to that of the cables it supports and for the same defined fire conditions. So what we need to do when we're sizing the support brackets, we need to accept that the drop rod and hangers must be sized to take into account the fact that tensile strength of steel will be significantly reduced in the fire situation. Now, the tensile strength of steel is about half what it is at ambient temperature at 500 degrees centigrade. So we have the strength is half for the amount of weight it can carry. So if we don't observe this design criteria, we will get premature collapse of the cable containment system. And the drop rods, the cross-sectional area of the drop rods is determined in accordance with Annex E, which is a quite simple arithmetic sum to work out what size drop rods you want, which you can see here. And what this is basically saying is, if as long as we know the weight of the cable and the weight of the cable containment we're using, and the span at which we're going to support those cables and that containment system, then we can calculate the size of the drop rod to take into account the weakening of the steel. Now, the theory is, as long as the drop rods and the trapeze remain in place during the fire, then the cables and the containment system cannot collapse prematurely. In this example, we've taken a 300 by 54 wire tray. We've put in a lot of circuit integrity cabling, and we put a support span at 2 meters. And what the sum tells us is we need to use a threaded rod of 12 mil. Now, if we don't want to use a 12 mil threaded rod because it's slightly too large, we want to standardize on, say, for instance, a 10 mil threaded rod. To meet the standard, what we can do is we can move the support in. So we've worked on a 2 meter support, so we could move the support into 1.5 or 1.2. Alternatively, we could split the cables over 2 trays and 2 supports to get the threaded rod down to a size we wish to use. Remember, 8519 only applies to circuit integrity cabling. But if we accept the standards and ensure the cable is supported for the correct number of minutes, we can also offer some other benefits. So, as I say, we worked out that in our calculation, with that weight, we would need to use 12 mil threaded rod. But what the methodology allows us to do is to take a span which is maybe smaller and see whether if we move the supports further apart, we still meet the requirements. I.e., if we move the supports further apart from potentially 1.2 or 1.5 to 2 meters, do we get a correct result for the size of the thread rod we want to use? We can therefore maybe reduce the number of supports we need in the building, reduce the cost of buying and installing supports, but also reduce the amount of steel we're installing as well. The wiring regs and BS 7671. So the wiring regs were introduced back in 1882. There was 4 pages, and they basically said, don't kill anyone, don't kill animals, and don't start any fires. And based on what we know today, we can assume that at least 1 or 2 of those things had already occurred. In the current regulations, were influenced by, as I said, the fire in Shirley Towers in Southampton. The College report echoed the report that had already been issued after the fire earlier, which influenced 8519. So they again said that because this fire and the deaths in the fire had been caused by the use of plastic products being used to support fire-resistant cables, it was important that any cable or fire-resistant cable should be supported by some sort of metallic product. Initially, this was introduced as a requirement for all cables and escape routes to be designed against the premature collapse in the event of a fire, but this was expanded in the 80th edition to cover all wiring systems in the entire building, not just escape routes. Wiring regulations Regulation 521.10/2002 states that warrant systems shall be supported in such a way they are not liable to premature collapse in the event of a fire. But we have to note there is no different definition offered in the 18th edition as to the time that defines premature collapse, or even a definition of what premature collapse actually is. We just need to ensure that we design our support so they won't prematurely collapse within the event of a fire for all systems. The Building Safety Act, BSI 644 Judicial Record, this is the result of the Grenfell fire, as you'll be well be aware, and the result of the independent review led by Dame Judith Hackett. And she introduced the idea of a golden thread as a tool to manage holistic systems, allow people to use information safely and effectively to design, construct, and operate their buildings. It also allows people investigating tragedies to go back through a digital record to see where changes were made and who made them, something they were found it very difficult to do after the Grenfell fire. So the Building Safety Act is law in the UK. A lot of the standards, in fact, all the standards and regulations we've spoken about so far are not actually law, they're regulations, and we volunteer to meet them. This is actually law, and there's primary legislation, and the golden thread is contained in the secondary legislation and specifically applies to what are known as HRBs, or higher risk buildings. And the golden thread should be stored as structured digital information. It should be stored, managed, and maintained and retained in line with the golden thread principles, and the government will specify digital standards which will provide guidance on how these principles can be made. So the first of these has come out, which is BS 8644-1/2022. So -1 indicates this is the first of a number of standards. And this is the digital management of fire safety information, design, construction, handover, asset management, and emergency response. And BS 8644 doesn't only, or isn't only written for HRBs. This is written as a standard which can be applied to all buildings. And if you are working between HRBs, high-risk buildings, and other buildings, you may find that running two processes is very complicated, and one process using the one standard would be much more simple. And the defining concept leading to the development of 8644 is really originates from the lack of available, accessible, and relevant fire safety information for assets across the built environment. And it's to enable relevant, accurate, and accessible fire safety information to be made available to the right people at the right time. And the introduction to the standard really is quite stark in what it says. And if we think about when fire stopping often is done, or fire stopping is often done, it's often done at the end of the project. It's often done to a standard and not to a design. So there is no design information available, and it's done after most of the other services have left site. So as it says here, it's often conducted in isolation. It's often done, the development is done by people working independently of each other. Asset owners rarely have a defined and structured fire safety information because it's often analog, paper-based, and managed using manual processes because it's not part of the visual design. It's been proven to be generally substandard, and it's difficult for the information to be accessed and updated. And the answer to this is building information modeling. So building information modeling becomes important because it allows the digitization as required by the golden thread. It allows us to put in product models and data templates into our design, which can be then seen in the future. It allows us to create a digital design supporting the golden thread, accurate parameter namings, and schedules and takeoffs. So BIM becomes, or building information modeling becomes, very important if we are following and want to implement the golden thread. So this is the background to what has become a growing demand for evidence establishing the performance of cable management systems in the event of a fire. And more questions have come in: what will happen? How will your product perform in the event of fire. Manufacturers of steel products, whether it be containment, whether it be fixings, point to the fact that steel is specified Euroclass classification A1 when it is non-combustible and does not contribute to fire propagation. If we think back to the cable chart we saw earlier, an ACA cable is non-combustible and doesn't contribute to fire propagation. And it'd be very difficult to test a product or have a meaningful test for a product which doesn't burn, i.e. you can't just put a piece of steel into a furnace and say, well, look, it hasn't burned, because we already know that is the case. And we must remember that the wiring regs clearly state that cables installed in or on steel cable containment systems are deemed to meet the requirements of the Premature collapse regulation. So by just using steel containment, we can meet the regulation 521.10/2002 without any additional need to include any other additional product. But despite this, the most common question from contractors and manufacturers of metallic cable management systems is, what is the fire rating of your cable management products? So the challenge for a cable manufacturer of metallic cable management systems is that the principal standards we manufacture to, BSEN 61537 or BSEM 585, do not have any requirement for product performance in fire. So how can a cable management system manufacturer fire rate their system where there is no standard to test to? By looking outside of the UK, and in reality there's no harmonised standard or any standard outside in Europe either, but in Germany there is a standard which is DIN 4102-12, which is primarily a test for circuit integrity cabling. It's created by DIN, which is the German equivalent of the BSI, but it does allow the installation of cable management systems in a furnace which reaches a temperature of 1000 degrees C. The test duration is over 90 minutes, and the test provides a measure of performance of the cables that can be installed on different cable management systems. So although they're testing the performance of the cable management system is in the furnace for a period of time, or the same period of time as the cable, and its performance can also be measured. So the standard itself requires the manufacturer to install their product into tracks. Each of the track will have a number and will have a product such as a ladder or a tray or a cable, a piece of trunking on it. Cables are then placed onto the trays. They are put in such a way that they form an S across the containment, and you can see on the picture on the left, additional weight is added in the form of chains to give the correct, or to give a more realistic amount of weight to that product, and the amount of weight is prescribed by the standard. Once you've prepared your installation and your containment is installed, it's then lowered onto a furnace. As you can see here, the ends of the product stick out through the wall and are fire stopped, and those cables, as you can see, are then taken back to the panel, which you can see on the left hand side, and that panel, each one of those cables is wired up to make a circuit. So the cable running through the furnace creates a circuit, and each one of those circuits lights a light bulb or a diode to indicate that the circuit is complete. The fire is then lit, and after a period of time, what we're measuring is when does that light or when does that diode go out. So as a cable management manufacturer, we're testing to understand what will happen to the cable management in a fire. This is what we're interested in, more than what happens to the cable. At the end of the test, we can see this is after 90 minutes. The temperature is up to 1000 degrees. It's done to a fire curve 1, which replicates what is an internationally agreed outcome of or what will happen in a fire. So the temperature is controlled. It starts fairly low and builds up slowly through up to 500 degrees, and then the last 15 minutes of the test, which is 90 minutes, are at 1000 degrees C, indicating how a fire in a building would actually burn. As you can see from the pictures, we've got trunking, tray and ladder here. None of these products have collapsed. None of the supports have collapsed. None of the containment has collapsed in that 90 minutes. So what this allows us to do by using the DIN 4102-12 standard is to say that despite there being no UK standard to test to or to refer to, it is possible to take your own action and address the issue of fire testing. So manufacturers can produce product declarations such as they do for cable in reference to the fire testing they've carried out on their products, and this is, will indicate whether the installation withstood premature collapse or resistance collapse, was what time that was, whether it achieved 90 minutes or longer. And this gives the ability to offer assurances to the contractors, to the consultant, to the client, for peace of mind. So if we think about evidence to support design, we know that we can use BIM, and when designing and installing supports to BS 8519-2020, we must follow the methodology to ensure that we design a support system which the standard tells us will support those cables for the correct amount of time as per the regulation. And we can install metallic cable management systems for wiring systems to prevent premature collapse to meet the requirements that all wiring systems are installed to prevent premature collapse, which is required by BS 7671-2019. But where we're being asked by clients and architects and consultants for as tested or fire rating for the cable management systems, then by specifying or going to a manufacturer who has independently tested their products to DIN 4102-12 and offers a declaration of performance, we can add to this assurance. And we are seeing more and more specifications coming out of consultants asking that the products installed have been tested to the principles of DIN 4102-12 at this time. So let's look to the future, which is obviously we can't guarantee. This is as we see it. So the Building Safety Act will take time to bed in. This is perhaps an unknown. We know, for instance, currently that the Welsh Government are talking about introducing additional legislation to ensure that, that rather than applying just to higher risk buildings, which are currently seen to be buildings which are above a certain height or have a number of stories, it will apply to all buildings of any height with 2 or more residential units in them. So that will be a much bigger challenge for people working in that area, because you'll have to go through a regulator, whether you're through the building regulator, whether you're building a very tall building or maybe just 2 or 3 stories. So the Building Safety Act will take time to bed in, and when it's developing and can change what it requires of us going forward as we go along. BS 644 will be part of a series of standards. We're currently only on part 1, and what we're seeing is that these standards again are being looked at as how they could be applied maybe to buildings, again perhaps not HRBs, but would it become a requirement of local authorities or hospitals that we are able to show that we're working to BS 644. The golden thread will obviously develop over the coming months and years, and if you do a Google search for golden thread at the moment, you'll see it brings up significant number of responses. Companies called the golden thread, consultants, golden thread this, golden thread that. So the golden thread is already very established in the industry, and then we have competency standards developing. So if we go back to James Haggett, one of the things that came out of the Grenfell disaster was, although in the case of fast-stopping products, for instance, the right product had been used, it had been installed incorrectly, it had been installed upside down, or perhaps in some cases it hadn't been installed at all. Doors hadn't been done correctly. And so competency standards are developing, which we suspect will be the focus for all of us over the next year or so, where we will all be being asked to prove our competency to do what we do, to present what we present, to sell what we sell, to specify product. And so we will the need to take more training, the need to do more of this type of CPDs will become paramount to ensure that we can prove our competency as we go forwards. So finally, in summary, I'm a little ahead of schedule, I think here. My clock is running a bit fast. So as we know, wiring systems must be adequately supported against our premature collapse in the event of a fire. So this was previously just a requirement of escape routes, but under the new wiring regs, this is for all wiring systems within a building. We must be looking to ensure that we use the correct products, and any product within a plastic type containment must also be supported by a metallic clip or a saddle to ensure that it cannot prematurely collapse in the event of a fire. We've got the formal introduction of competency and understanding, and this obviously understanding 8519 and the wiring regs is part of that competency, making sure that we're using the right products in the right places. A CMS system must have a fire resistance under 8519 equal to the fire survival time of the cable is supported. And as we say, there is no UK standard which stipulates fire testing for cable management systems, and there's no standard to test to in the UK either. So as a manufacturer, you can't go out and make up your own test. And there's no UK standard either to define premature collapse. So by looking to the German DIN 4102-12 standard, which is a test for circuit integrity cabling, we can provide peace of mind that the products we're using have been in a furnace, have been tested and fire rated for a period of time, and will give us an indication that they won't prematurely collapse within the time scale that we're looking for. For further learning, you can go to the Legrand website. We have areas there called solutions, which has a whole section on fire. We also have the ability, you can download BIM models of our products there as well. Unfortunately, the files that foretold the Grenfell tragedy is no longer on the iPlayer. Hopefully it may come back in the future. We can look at knowledge of the standards we've spoken about, 8519 and obviously 7671 will ensure we have the knowledge to make sure we meet the requirements. And additionally, there's an additional Legrand CPD called Creating Cable Pathways, which covers in more depth those standards we've spoken about. So as I say, slightly earlier than expected. I would like to thank you for your time, and I can now take some questions.
Yes, thanks, Paul, for the insightful session. I do apologise for the sound issues that we had earlier on, but just to reiterate, if you do have any questions, please do feel free to add them into the Q&A bubble that you'll see on the side, and that'll come over to us. We can follow up any unanswered questions via email as well. So just to start off with, can you just remind us what's the distance between supports for the test?
For the fire test that you saw there, the supports were at two distances. So for the heavier ladder products, the products were supported at 1.2 meters, and for the lighter trays, the supports were at 1.5 meters.
Thank you, Paul. And what was the size of the threaded rod that was used?
Again, there was two sizes used. So for the heavier products, they were supported on a 12mm threaded rod, and again for the trunkings and the lighter trays, they were on a 10mm threaded rod.
Okay, thank you. Got a couple more.
Okay.
Does the golden thread legislation apply to all buildings?
No, so the golden thread legislation is particularly only for applies in England and Wales, and some parts apply in Scotland and Northern Ireland, but in England and Wales it only currently applies to higher risk buildings, and the definition of high risk building is contained within the Building Safety Act as well, but it's buildings of a certain height or a certain number of stories.
Thank you. And just one more then, how do loading tables and supports help to control costs?
So as we saw, if we can use the manufacturer's loading tables, which all manufacturers are required to publish under the standard to make available to people using their product, manufacturers will show a range of support distances, probably starting at 1 meter or even less, through to maybe over 2 meters, 2.5 meters. And quite often we get into a routine of always supporting a certain distance, because that's what we've always done. If we go back to those tables and look at those support spans, we may well be able to expand or to increase the distance between supports, removing supports from as well as which removes cost and steel. But we can also double check that against the 8519 calculation we want to. So we can use the 8519 calculation to confirm that we're both meeting our requirements under premature collapse, but also giving us the opportunity to confirm that by increasing the span, we're not increasing the risk of premature collapse.
That's great. Thank you very much, Paul. And thanks everyone for joining. Just a reminder that the CPD certificates will be emailed directly from CPD, and this will take up to 4 to 5 weeks. If you have any inquiries after the webinar, then please send them over to marketing@rexel.co.uk. That's marketing@rexel.co.uk. Thank you, everyone, and Paul, once again, for your time today. We look forward to having you in our future webinars. Thank you.
Thank you very much. Thank you.